Okay, here, you're gonna record it?
Yeah.
If you want to, you can just sit there
Okay.
and I can. Okay, so when we look at the drawing, it tells us the dimension of the whole final assembly. Okay, so it's already put together. So as we look at this, we want to know what the sizes of the individual parts that are going into it, right? So where this part fits into this assembly is here at the aft edge of the airfoil. So it's called an aft spar. So what we have to do is we measure from the outside bottom to the outside top. So we're measuring this right here. So if we took a caliper and we measured this right here, it would be 2 7/16. So I've got that listed right here, 2 7/16. But we have to remember that we have a 40,000 skin on the top and a 40,000 skin on the bottom. So we have to subtract the sum of 40,000s plus 40,000s.
80,000.
Which is 80,000s, exactly. So here we've done the math. Now, the first thing you have to do is, instead of using fractions, divide 7 by 16, and that will give us the decimal equivalent of 7/16, which happens to be 4.4375. Okay, so it's 2.4375. So now that we've done that, we subtract the 80,000s. So from there, we come up with the number of the actual size of the aft spar. So the actual size of the aft spar that we're making, when it's finished, is supposed to be 2.357. Okay, so now we're gonna go and lay out the entire part from start to finish. So just like we do here, we lay out the entire parts from start to finish. So we're gonna have 3 sides to this part. It's gonna be 0.75 here, and now we call these the mold lines, okay, mold line dimensions. So this side's gonna be 0.75, this side's gonna be 2.357, this side's gonna be 0.75. Okay, so that's the finished size. Now we have to calculate, lay that out. So in order to do that, we're gonna have to draw onto a piece of metal, or you can do this ahead of time on a piece of paper. Some people like to think of this ahead of time and lay it all out. So I'll just draw it on the board. Now, remember when we did the 2" by 2" by 2" U, we did it on a 1" wide strip of metal, right? We're going to be using a 9" wide strip of metal. Okay, so just have to remember that fact. So sometimes, okay, so this should be 9 inches. I'm not drawing it to scale, but sometimes in a drawing, what they'll do is they'll make a little thing like this in a drawing, and that means, okay, and then they'd say 9 inches. So that would be 9 inches from there to there, right? So that just kind of shows that we're just showing this condensed. Okay, that doesn't have anything to do with you calculating. So the very next step would be, we take our 3/4 and we subtract 1 setback. And remember, setback is equal to radius plus thickness. So in our case, the radius we're using is 1/8 inch. We've converted to 0.125. The thickness of our sheet metal is 32 thousandths, right? 0.032. So our radius is radius plus thickness. So that's gonna be 0.157. That's our setback, 0.157. So that's the number that we're gonna use quite a bit in this project. Okay, so we take the dimension of the size we're making on that side, and that happens to be 0.75. I've already done the calculations here. That's 0.75. Now we're going to subtract 1 setback, and we come up with a 0.593. Now you should already be aware of that because you were already doing that, right?
Yep.
Okay, so now when we transfer this to our piece of metal, we just measure in, 0.593, and do that as accurately as we can. I'm just going to simulate it here and put my first bend tangent line. So we call that a BTL, right? BTL, and we're gonna call that number 1, BTL number 1. Okay, so that measurement here is 0.593. Okay, now it's time to add bend allowance. So we go to the chart in our textbook or the AC43, and we find bend allowance on a chart. And remember, there's going to be 2 numbers on the chart. There's 2 numbers in a box. So we have to know what the thickness and the radius is, and we look at the chart and we determine that for a 90-degree bend, we use bend allowance of 0.218. So that's what we're going to add to this number right now. So I measure over 0.218, so that comes to here maybe, and I draw that in. Okay. Now, we call this flat A. We're going to call this one flat B, and the final one we're going to call flat C. So now we're going to determine flat B. Okay, so we have to know what the overall dimension of that part is, and we've already talked about that. That's the height of this part right here.
Right.
So we said that's got to be 2.357. So in order to figure that out, what we have to do, someplace where I can calculate, I just wipe off some of that stuff, get it out of our way. Okay, so what we're going to do here is we're going to take that overall size of 2.357, and we're going to subtract setback. Now, there's a bend on this side, and there's a bend on this side. So how many setbacks do we have to subtract?
2.
2. We have to subtract 2. So we're going to go ahead and take our 0.157, we're going to multiply that times 2, and we get 0.314. Okay, so now I have to subtract 0.314. 0.314. And whatever that is, happens to be 2.043. Did the math already. 2.043. Now I'm going to measure over from bend tangent line number 2 to establish my bend tangent line number 3. And we're going to do that over here, right there. And that's bend tangent line number 3. Does that make sense?
Yep.
Now we have to add bend allowance. This right here is called bend allowance, so we call it BA. And it was 0.218. We know it's the same over here. So it's the same here, so it's 0.218. Okay, so we just go ahead and 0.218. There we go. Now, in order to get C, it's the same exact dimension as A because it's the same dimension, right? So we know it's 0.593, so we go ahead and measure that out. 0.593, and it's going to be somewhere about here. So we draw that in. Now we know that's going to be where we cut it off, and I always mark my cut so I don't forget and get confused later. So now we go ahead and we figured this out on paper. Now we do the exact same thing on a piece of metal. We got one more thing to do though, and that's put the sight lines in. Do you remember the sight lines?
Yeah.
Okay, so right now they look like the center line on a highway, but we have to figure that out. So the sight line is determined by the radius of the bend. And we're going to use 1/8 inch radius, so we're going to use that 0.125 again. So I'm going to come in the direction that you put this part into the brake. So we put it in the brake and we clamp it. So let's say this is the brake. We're going to come in from this side. So we go from this bend tangent line inward, 0.125. So it's a little over halfway. Okay? In this particular case, it's not always that way, but just because what we're doing here, it's that way here. So we go ahead and sometimes I like to do a dotted line or at least make a different color line. Okay, that's going to be our sight line. Now we go to the other one because we're going to have to bend this and we're going to put it in from the other direction. So we're going to measure it from bend tangent line number 4, right? We're going to come inward 0.125. So I do that. Now we're ready to go out and bend it up. That's how we do it. Should fit first time, hopefully. If all of our measurements